In Star Trek IV, The Voyage Home, have you ever seen it? It came out in 1986. The crew of the original Enterprise go back in time to 1986. Anyway, there's a scene where Chief Engineer Scotty describes a lighter, sturdier, futuristic alternative to plexiglass. Transparent aluminum. This stuff is supposed to be so strong that it makes up the viewports of the Enterprise. The coolest part, though, is that this stuff is not just science fiction. Transparent aluminum actually exists, and it pretty much lives up to Scotty's hype. And it's just one of many cool new materials that seem like they were plucked straight out of science fiction. From invisibility cloaks to self-repairing concrete, the future is now. Aerogels are one of the lightest solid materials in the world. Gels are mostly liquid, but they act like solids because there's a bunch of molecules in them that link together and hold the liquid in place. Aerogels are gels where the liquid has been replaced with gas. Imagine taking your favorite gelatin dessert and sucking out all the water, but instead of crumbling into a powder, it still keeps its dome-like shape. That's basically how scientists create aerogels. First, they make a gel out of something like silicon or carbon compounds. Then they use extremely high temperatures and pressures to blur the line between the liquid and gas phases, creating a supercritical fluid. Then the kinda liquid, kinda gas can drift out of the solid molecular structure and be replaced by air, so you have a porous, lightweight material that retains its shape. Aerogels are great for insulation because the air inside doesn't transfer heat very well, so they're mostly being used in spacesuit and spacecraft linings. Plus, they're almost transparent, which means we could use aerogels to insulate windows here on Earth. When they get cheaper. If you're a Harry Potter fan, chances are you've wanted your own invisibility cloak. But instead of using magic to make things invisible, Muggle researchers need to experiment with light. We don't have large-scale invisibility cloak technology yet, but scientists are working on a lot of different ideas, like creating flexible sheets of liquid metal that can block radio waves used in radar. And we're getting closer. In 2015, scientists designed a very, very thin material, like 80 nanometers thin, that could hide equally tiny objects. In order for us to see an object, light has to bounce off of it, and any distortions of that light reveal its shape and features. This invisibility cloak uses teeny tiny brick-shaped gold antennas to counteract that natural light distortion. So when this cloak is wrapped around an object, any light bouncing off of it looks like it's coming from a perfectly flat mirror, hiding the fact that the cloak and object are even there. And theoretically, you could adjust the gold antennas to make the reflected light look like any object or background. This technology only exists at a microscopic level right now, so scientists need to figure out how to scale up the idea before we can make larger objects, like people, invisible. So we can't quite make objects invisible, but what about super waterproof or super hydrophobic materials? I'm talking way more waterproof than your average raincoat. Scientists are trying to find ways to mimic the waterproof surfaces found in nature, like the lotus leaf or certain butterfly wings. And it turns out that microscopically rough surfaces tend to be more hydrophobic because they can trap pockets of air and minimize the interaction between water droplets and the surface of the material. So scientists can make coatings that have things like aluminum oxide nanoparticles in them to make surfaces rougher and repel water. Another idea is to make surfaces that are covered in itty-bitty ridges or polymer cones that are just tens of nanometers in size, thousands of times smaller than the width of a human hair. These materials are so waterproof that water droplets actually appear to bounce off of them and even split into smaller pieces. By putting this stuff on electronics and medical devices, we can protect them from water damage, but these materials may also be someday used to keep ice from forming on cars or algae from growing on ships. Carbon is amazing, like the basis of all life as we know it amazing. We've talked before about how awesome some carbon-based materials are, like graphene, but we can use what we know about carbon to make a material even harder than diamonds. Aggregated diamond nanorods, or hyperdiamonds if you want to sound cool. These are the hardest, most dense, and least compressible material we know of. Diamonds are hard because of their molecular structure. Each carbon atom forms 4 covalent bonds with the atoms around it, which forms an exceptionally hard crystal structure. In hyperdiamonds, that's still true, but it's a different, more wear-resistant form of diamond. This material is made up of many tiny interlocked diamond crystals rather than one single structure. They can be made in the lab by applying extreme heat and pressure to graphite. Diamonds are frequently used for industrial jobs like grinding and polishing because they're so tough. But hyperdiamonds could be even more useful than regular diamonds because they're even more resistant to the temperature and pressure changes that can wear diamonds down over time. Now, when can metal also be glass? Well, when engineers invent metallic glass, also known as amorphous metal. Most metals have a crystalline structure. The atoms are ordered into a specific repeated pattern that makes it stiff. But glass has a random arrangement of atoms, which makes it more brittle. So metallic glasses form when metal atoms are in this random arrangement, like when melted metal is cooled really, really quickly before its particles can arrange themselves into a crystal. This material has the best of both worlds, the malleability of molten glass combined with even more strength than crystalline metal. This combination of high strength and low stiffness makes it really resilient resilient. It can store and release elastic energy better than other forms of metal, which means it doesn't deform as easily. Right now, metallic glasses are being used as coatings to make objects more corrosion or wear resistant, or to make products like golf club heads. But eventually, the material could be used to easily manufacture things where strength and weight are concerns, like lighter, stronger car parts. But glass isn't the only hot new metal material. Metallic foams are made up of a metal like aluminum and a whole bunch of gas-filled pores. This makes them super light, plus they keep many of the original properties of their metal, like being strong, fire-resistant, and conducting electricity. Metallic foams can be made a few different ways, like by injecting gas into a liquid metal or by causing the precipitation of gas that's already dissolved in a metal mixture. And some are open-pored, meaning that the gas pores inside are all interconnected, creating what are sometimes called metal sponges. But in closed-pored metal foams, the little bubbles are all separated, which means they can float in water, which could be helpful for building sturdier, lighter boats and spacecraft that can make water landings. In general, metal foams are useful for high-tech shock and impact absorbers. The gas inside makes them extremely compressible, so they can absorb a lot of mechanical energy while still retaining some of the strength and durability of a metal. This means they also have a lot of potential for building different car components that are light and sturdy. Some metals also have unique new uses, like aluminum. In Star Trek IV, it's called transparent aluminum, but that's kind of inaccurate. The material our scientists are manufacturing is really aluminum oxynitride. It's composed of aluminum, oxygen, and nitrogen. It's a ceramic, which means the material starts as a powder and is then heated up until it melts, then cooled into a crystalline structure similar to glass. It's basically transparent and extremely strong, nearly as hard as sapphire, so aluminum oxynitride is really useful for things ranging from bulletproof windows to super durable camera lenses. It's still expensive to make, but hopefully we'll find ways to make it more efficient by the time we get around to building starships. Concrete. I'm sure you're familiar with it. Just today you've probably walked on it or sat on it. In fact, it's probably all around you right now. But as materials go, it's not very cozy. The invention of light-transmitting concrete hopes to change that by interspersing very thin layers of concrete with optical fibers. This means light can be transmitted from one end of a concrete block to the other. The translucent concrete maintains most of its strength, so it can still be used for heavy-duty projects like constructing buildings or roadways, or it can be used in otherwise difficult-to-light areas like subway tunnels and walkways. Unfortunately, we haven't found a way to pour this stuff out on site like traditional concrete, which means it's not really practical yet. Mostly it's used in art installations or very small areas. But with some more research, fancy glowing sidewalks may become the new normal. Now, what if we could increase the lifespan of concrete that's already been poured? Enter self-healing concrete. Invented by scientists in the Netherlands, the basic concept is to combine engineering with microbiology and embed bacteria that can create limestone directly in the concrete. During normal seasonal changes, concrete shrinks and expands and eventually cracks. This lets water seep in, causing even more damage. But self-repairing concrete contains biodegradable capsules that are full of bacteria and their food source, in this case calcium lactate. The bacteria lie dormant until the water seeping in dissolves the capsules and sets them to work, eating and multiplying and producing calcite, or limestone, from the calcium lactate, which fills in the cracks. These bacteria can survive up to 200 years if there's enough nutrition embedded in the concrete. Currently, the bacteria can only heal very small cracks, but eventually this technology could fill larger breaks, which could be huge for fixing roads and building more durable buildings without hands-on construction time. So scientists are developing all kinds of new materials with incredible properties and weird new uses. Soon, we'll be building the future with all these technologies and more. Someday, Scotty will have been proven right. Thanks for watching this episode of SciShow, brought to you by our patrons on Patreon. If you want to help support this show, just go to patreon.com/scishow, and don't forget to go to youtube.com/scishow and subscribe.
Another metal that's turning out to be a useful weapon against bacteria is silver.